I'd like next to welcome a longtime user, Simon Burke, CAD architect at Xilinx. Dr. Simon Burke is a distinguished engineer at Xilinx in San Jose. Prior to that, he was doing work at SGI, ATI, AMD, and a host of other places that have been cutting edge. Simon, thank you for joining us today, and we look forward to hearing what you have to say.
Okay, so I'm from Xilinx, the other FPGA company. That won't be at the end of the table there. So I'm going to talk to you a little bit about our experience with IC Manage and the way we use it and some of the things that we see and observe from it. So just in terms of trends that drive our data management and the problems that we see, in general, at least for our business, we're seeing the number of projects grow each generation. The time to tape out doesn't seem to change, the time to market doesn't seem to change, the products just get harder to do and more of them. We do try to actively manage our silicon risks down. We try to reduce the number of tape outs that we do. Obviously a goal for everybody probably. We just don't have the resources to extensively spin after tape out. We do have to try to manage that down. So bug tracking and tracking out good known silicon first time is a very high priority for us. What we do see is as we go down the process nodes, our design complexity just keeps going up. We're seeing between about 1.3 and 1.6x growth per process node in the same amount of time as we've done before. What we are doing is using a lot of multi-geos to try to address that problem. So we have sites around the planet. We are using them 24/7 to try and get our chips out the door in the same amount of time. That means data's got to be available in India pretty much the same time it's checked in here. You can't afford to be waiting a couple of days or hours even to get that over there. And the real challenge on the database side, in my opinion, is just keeping the lid on all that stuff and not having it explode. As Yaron said, you want data management to be boring. You just want it to work. You have other problems to deal with. That's where you want to spend your time. So a couple of trends that we see. We actually did our transition to IC Manage just between the 40 and 28 nanometer node, and we migrated our 40 nanometer database into IC Manage so we didn't have to maintain two legacy systems, or two systems. As I said, we've seen our products grow about 25% per product node. Our growth business is in markets we don't address today. That needs new products to go after them. That's what we do. Our tape-outs have actually been going down over each process node. We tape out less chips in 28 than we did in 40, and we will hope to do the same thing at 20 when we eventually tape out 20. That is a testament to us trying to get the silicon risks down in each initial tape out that we do. The tape out per product is also going down correspondingly. Even said that, what we do see is a 1.4x growth in man effort just to get the chips out the door, and that's been happening over the last two process nodes. It just takes more effort to get the chip done. So corresponding, we are seeing between about a 1.3 and a 1.6x uptick in data management activity in general. People checking more stuff more often. That means we have to grow our data management system to cope with that and have it be scalable. Having something that's on the brink of what it can do today is just going to fail next time if that's the case. So we need to have a system that has a lot of headroom beyond where we currently are at today. So as I said, man effort is really growing about 30% a node as far as we can tell. ICM activity is going up about 6% per node. What that really means is not only are we checking in more stuff more often, we're also doing more iterations to fix it to make it work. So you're seeing more work in between those check-ins, which goes to our increased resources. And our depot size has been growing about 20% per node. So our 28 nanometer database was about 20% bigger than our 40, and our 20 is about 20% bigger than our 28. So the scalability on the data management side is also growing with that complexity growth. So don't buy too small a disk, buy a big one. Make sure you got lots of room. So in terms of the critical dependencies, what does that mean to us from a data management system? What we really want is a central repository of data. Having data in different systems just doesn't work. There's too much of it, and it takes too much time to track down. So knowing where your data is for each product and tape out really helps you get the tape outs done. What we want to do is not have that unfortunate risk of taping out your chip with the wrong piece of IP in or a bug fix that got missed. That's expensive. It takes a lot of dollars and a lot of time from our schedule. We just can't afford to do it. So knowing what you're taping out and where it came from is very important. We currently have about 1,800 IC Manage libraries across our product portfolio, and those are individual functional blocks that we have to manage and track to get into our products for tape out. Branching is, again, fundamental to what we need to do to tape out chips. Each product we tape out, we essentially create a branch of it so that we have a known database that we can reference back to, and we have a rolling branch model for our product tape outs. So we have a significant number of branches, but within those branches, We can obviously track back where the IP came from, what version it came from, and as there's a bug fix, we can update those branches with those bug fixes and move forward to a new tape out. So it lets us do the tracking of what bug fixes we did whilst keeping the database intact. We have about 450 IC Manage libraries to track in a typical product. Sounds like a lot, but when you add up cadence data, RTL data, IP, it mounts up very quickly. Having those in a spreadsheet is just too much work. So what we do want is leverage the power of IC Manage to go track those 450 IC managed IPs and libraries into our product so we know this is the thing we're taping out, this is where it came from, and if we have an update to one of those, we can go track that successfully. And then security is, as we try to grow resource to get our chips out on time, we are starting to pick up resources from all over the globe, some in our existing sites, some not. There is a security aspect to that, especially with bought-in IP or data from fabs who are very particular about who we show out their data to, as to who can see what. So having good security on top of IC Manage is important to us, so we can restrict who's allowed to see which data. We can't just make everything available to everybody. It's not the world we live in. So a couple of data points for you in terms of at least our experience. This is across the 28 and 29 nanometer nodes. As I said, we did the transition between 40 and 28. To date, we haven't had any corruption of data or loss of data that's actually been checked in, not one byte that we can tell. We've had 0 tape outs due to a respin of wrong IP being taped out. That was not true before we switched to IC Manage. I'm not going to say IC Manage is the reason that happened, but certainly it helps us get to that goal. So to date, we've had no retape outs due to wrong IP being inadvertently taped out. In terms of our proxy availability, and we have proxies across all of our remote sites, we're at about 3 nines uptime, 99.9% uptime, as best as I can tell. That goes to the, you want this stuff to be boring. You don't want it to just break. Every time it breaks, people go home and you don't get work done. On the server side, we're more like 99.5% uptime. Now that's excluding scheduled downtimes where you have to do patch the OS, you have to update versions, etc. We can schedule those for times when it doesn't matter to our design teams. What I'm particularly talking about is where it does matter to our design teams, where we're trying to get chips out the door and people are sitting at the desk waiting for you to fix something. We have about 5 global sites that we coordinate all our design IPs. So when someone's doing an IP, it's got to come from that global site to the site that's doing the tape out. And we have 2 sites that do tape outs across our organization. So typically seeing data come from one remote site to one of the 2 tape out sites. That has to happen quickly. You don't want to have your integration teams sat around waiting for data to show up. So there is a data management problem, just making sure everything syncs around. So those are kind of our experiences at 28 and as we walk through 20 that we're seeing with our current data management system. And I would concur what Aaron said. For the most part, you want this to be boring. You don't want it to be exciting. That's all I had. Thank you. So the way we manage that at Xilinx, we have exactly that problem, of course. We tend to break our CAD environment into project-based CAD, and then we use the IC Manage auto-syncer to push out a version of the CAD environment that goes along with that project. It's managed inside IC Manage along with all the verification test benches and the RTL itself. So when we do snapshots, we snapshot it so we have a copy of it. But in terms of usage model, the verification data and the RTL data is in the workspace, and you just point to an auto-sync mirror of the appropriate CAD versions that go along with that environment. And we track them on a project basis. Those are compromise. I mean, that's really across the whole data set. That includes RTL test benches, cadence data, place and route data, CAD libraries. So that's the complete set of libraries that describe a project. Typically, the CAD guys will only check out the CAD libraries. The RTL guys will check out RTL plus test benches. Somebody running LVS will just check out the cadence data. So we very rarely see a single workspace that has all that stuff in. That'd be big. It'll take a while to sync, and nobody really cares about 90% of it. So we have multiple workspaces, multiple configurations set up for the individual design teams to kind of pull out a subset of the data that they care about. We do tend to treat those as outside the regular design database. We don't put them in the main design library. We keep a separate library because they do change pretty much every time we do a tape out and every time we do an ECO and they are big. And we don't want to maintain, there's no value to maintaining previous versions of those things. You just really want the latest one. So we do manage those as a separate library attached to the main design IP that we can discard if we need to. It depends on the size of the IP. Some is, some isn't. The top level build, for instance, would not be stored in IC Manage because it's too big and we just regenerate once and merge it on the GDS side. Low level IPs we do, as an example. Yeah, and to that point, the way we actually manage them is when we tape out, we create an integration branch of the data we're about to tape out, and that's where the C fields go, not in the main database.